Hi, myself Manjunath from the Department of Electrical and Electronics Engineering of KLSVD Halial welcomes everyone for this session on the subject testing and commissioning of power system apparatus, which is an elective for the 7th semester having the subject code of 17EE752. In the previous session, we have the topics related to duty cycle, drying of on the machine, the measurement of insulation resistance, as well as the measurement of the armature and field winding resistance. And afterwards, we have seen the power frequency withstand voltage test. When we say the duty cycle, this information will be provided and the nameplate details or maybe rating plate details for which particular electrical apparatus or maybe machine is rated. Now, as per the standards, we have the different duty cycles with the symbol of S1 to S8. The example being that is, it may be the continuous rating machine, or maybe short-term intermittent, or maybe intermittent. Each one of the duty cycle having the symbol of S1, S2, S3, S4, S5, S6, S7, S8. All these are named according to the Indian standards or maybe the internationally recognized standard International Electrotechnical Commission. Then afterwards, we came to know about the need of a drying. As you know that in case of electrical machines or maybe electrical equipment, will be having a cellulose insulating material. They will be in they will be having a property of absorption from moisture content. Once the moisture content is absorbed by the insulation, the deterioration of insulation takes place or maybe its insulation resistance decreases. To bring back the insulation resistance to its original value as per the standard, we require a drying of an electrical machine, similar way that a drying of a synchronous machine is done. With the different method, the common method what we have seen is the short circuit method we have seen in the previous session. Afterwards, we went on to measure the insulation resistance. There are many factors are there because of which the insulation resistance reduces. Once it reduces, we say that it might have lost its insulating property, or maybe the insulation is going to gets deteriorated. Therefore, in order to maintain the specific value as per the standards, that drying is essential. During the drying process, that INR is measured. This INR is measured with the help of the equipment or a device, the mega, or maybe any of the method which is capable of measuring the insulation resistance in terms of a mega ohm. Because since the insulation resistance will be in terms of mega ohms, any method which is available for measurement of the insulation resistance in mega ohms, that can be used. Then afterwards, in the same way, the field winding resistance as well as the armature winding resistance are measured with the help of any bridge method which are available in the particular site or maybe in the factory, so that the armature and the field winding resistance are measured. Then afterwards, we started with the testing, that is power frequency withstand voltage test. We apply the specified voltage according to standards to the machine for 1 minute. If it withstand without the failure of insulation, then we say that that equipment has passed the test. That's why we say it as withstand voltage test. That is, we applied some voltage to the electrical equipment for 1 minute. It will be above its rated voltage, and as per the standards of Indian standards or maybe the International Electrotechnical Commission standards for the particular the rating of the machine. That what you see in the previous session. In this session, we are going to have the two tests. Normally we call it the OCC test, that is open circuit test. Then afterwards, other will be going to SCC, that is a short circuit test. Then from these two tests, you're going to find out the short circuit ratio. Those things are maybe short circuit SCR is determined by knowing the test results of the open circuit test as well as short circuit the test on an alternator. After the class, the student should be in a position to explain how that open circuit test can be conducted and what is the importance of the conducting the open circuit test. Then similar fashion, they should know how to determine the short circuit ratio by the test data which is obtained from the open circuit test or maybe the short circuit test. Similar fashion, they should be in a position to explain how SCC short circuit test can be conducted on an alternator. What is the importance of the particular SCC test on the alternator? Now let's go one by one. That is open circuit characteristics. It's also named as a no-load saturation test. It's also named as no-load saturation test. Now, especially these open circuit tests and short circuit tests are helpful in determining the regulation of an alternator at different load conditions or maybe at full load condition only. Maybe there are two methods are there, and maybe the pessimistic method or maybe optimistic method, so that you can find out the regulation of alternator. First, let us go before going to that particular aspect of this why these parameters are required, what we are going to get it from these parameters after the test. This, as I said already, this also named as no load saturation test. In this test, the alternator is connected as shown in the diagram here. It is coupled to an induction motor, and in case of this one it is a prime mover. I'll be considering that a prime mover. Induction motor is coupled to three-phase induction motor is coupled to the alternator, and we give a DC supply to the field winding. As it is, it's either separately excited machine. That's why we give excitation voltage. After making the connection here, as it is in the circuit, we keep to the maximum resistance position, then keep the stator terminal open, and we start the induction motor with the help of any method, maybe that directly on line starter, DOL starter, maybe auto transformer starter. We apply the rated voltage to the three-phase induction motor. When you apply the three-phase induction motor voltage to the three-phase induction motor, rated voltage to the three-phase induction motor, it runs its rated speed. Since it is connected to the alternator, hence this also rotates at its rated speed. Afterwards, what we do it here we connect a multimeter or voltmeter across the line terminals. We go on exciting the field winding in steps. Ready? It is in the highest resistance position, then go on decreasing the resistance, and each step of increase due to the decrease in the resistance, the automatically field current increases. As the field current increases, the amount of voltage induced across the stator winding goes on increases. Therefore, what we do it here, the go on increasing the field current. At each step of increase of the field current, we note down line to line the voltage, that is it is, and afterwards is tabulated here. It is simple procedure as such. That is what you do it in case of this one. We run the alternator to its rated speed with the help of induction motor. Then afterwards we go on exciting the alternator in steps, so that the field current gets increased in steps. At each increase in the field current, we note down line to line voltage with a multimeter or maybe voltmeter connected across the line to line. That will be tabulated here. This process will be continuing until the rated voltage comes across the line to line, maybe 415 or 440. If you're connecting between the phase, it is 230 is sufficient. That is, if you're connecting the voltmeter between R and Y, that is, I have to increase the field current until we get a 440 volts or 415 volts, for which particular alternator is designed, and afterwards tabulate it and obtain the phase values of the no load induced, or maybe no load terminal voltage. We call it as no load terminal voltage induced, or maybe terminal voltage induced across the stator terminal when the alternator is under no load condition. Then afterwards the phase voltage is determined. Then we draw the graph between the x-axis field current and the y-axis no load EMF induced per phase is comes under y-axis, and you're going to draw the specimen graphs you're going to get. Therefore, this will be calling it as the OCC. This will be calling it open circuit the characteristics. Open circuit the characteristics. In this way, you can determine open circuit the character. It is the open circuit character nothing but it is a variation of the no load terminal voltage induced with respect to the field current. With respect to the field current, that we call it as a OCC. That we call it as a OCC. Now let's go to the second one, the short circuit test. Now in case of this one, the same figure what you have seen in the previous slide will be there with a little bit of a modification. Only the modification what I do it here, we are going to short the stator winding with an ammeter. That is the modification what we have done, or maybe the connection change that going to take place in case of a short circuit test. The only thing is, in the previous we have kept open the stator terminal. Here I am going to short it with an ammeter of the specified rating according to the nameplate details of the alternator. Other thing remains the same. That we keep it at the maximum position, and we connect the induction motor as a prime mover to the alternator, to an alternator. Here what we do here, we once again start the induction motor by giving the supply to it at its rated voltage with the help of a DOL starter or maybe auto transformer. So when we give a rated voltage to an induction motor, it starts at its rated speed. Since the induction motor is coupled to alternator also rotate at its rated speed. Then afterwards the procedure is simple, that is go on exciting or maybe increase the field current until this ammeter shows a full load rated current of an alternator. That is rated current of an alternator. Until the rated current of the alternator is obtained in this ammeter. That what we have done here, we started the induction motor by supplying its rated voltage. When it is rotated at rated speed, the alternator also rotates at rated speed. Then we go on exciting the field current such that at some particular value of the current, the field current, this shows a rated current. At the time, you have to note down this field current as well as the short circuit current, that is rated current. Only one reading is sufficient. Afterwards, you are going to draw the graph like this, that is short circuit current on the y-axis and the field current on the x-axis. We get the graph like this. Knowing these the parameters of the OCC as well as SCC, we can calculate the regulation of an alternator by the EMF method or maybe MMF method. There are two methods are there which are available as per the standards, by which you can determine the regulation of an alternator. That is, those methods are the EMF method as well as the MMF method. Those information that your people have studied in case of the third semester or the fourth semester while doing the theoretical part of on the alternators, or maybe in case of a laboratory for determination of a regulation using the EMF method and MMF. That complete information is not needed for especially for this topic as such, that is testing and commissioning of power system of apparatus. These two, how one can find out the OCC as well as SCC is sufficient for the determination of regulation using the MMF method or maybe EMF method, may not be given much importance in case of this topic as such. This about the determination or maybe the conduction of OCC as well as the SCC SCC on an alternator. Let us see what is the importance as such. What is the importance of this one? Already we have seen that these parameters are a graph what we obtain from the OCC and SCC, further helpful in this determination of regulation of an alternator, the alternator. Or the one more distinct aspect is that is the determination of a short circuit ratio. That will come onto the next slide. This is the meaning of the short circuit ratio. How one can determine? You can see that one. In the previous, I had given a little bit of information about the OCC as well as the SCC, how it can be conducted. But in case of this one, it is one more test which helps us to find out the short circuit ratio. Now, you can see that the short circuit ratio is determined from a data of no load and short circuit test conducted on alternator. That's why I said that the importance of the OCC and SCC never stops, will not stop, never stops and will not stop as you get the regulation as well as the regulation by MMF and EMF method. Further, it is required to find out those things are required to find out the short circuit ratio. That's why you can see that short circuit ratio is determined from a data of the no load and short circuit test conducted on alternator. That's why it becomes important there. The short circuit ratio is defined as, let us define it now, defined as the ratio of a field current. The SCR, the short circuit ratio, is a numerical value. It is ratio of two field currents. It is a ratio of two field current. Now we'll see that what are those the field currents. Therefore, the short circuit ratio is defined as, you can see that definition there, is defined as the ratio of field current which is responsible for inducing the rated terminal voltage in the stator winding. Stator winding. That is, therefore you can see that it is the field current which is responsible for the inducing the rated voltage during the open circuit characteristics. That you already seen in case of open circuit characteristics, the value, that is the field current at which the rated voltage is induced, that will be the part of a numerator. The one more thing is other field current is the field current which circulates the full load rated current in an alternator when running at its rated speed. Therefore, it is the ratio of two field currents. One field current which will be responsible for generation or inducing the rated voltage across the stator windings under no load condition. That information we get it from OCC. And the denominator part is a field current which circulates the short circuit current. When I say the short circuit current, it automatically the parameter what we get, or maybe data what we get from the short circuit test. Therefore, this is the SCR is the ratio of two field currents. One is taken from numerator part is taken from the open circuit characteristics, that what we have seen in the previous slide, and once again the other denominator field current what we get it from the short circuit the characteristics test, that what you've seen once again in the previous slide. The ratios will give a short circuit ratio. Therefore, the graph what you can see it here, this is the two graphs that is obtained what I already shown with the specimen. Here once again the specimen to determine the value of the SCR. You can see that one. The curve, what I'm going to draw it here, it is OCC curve. Now this is the rated voltage. Maybe in terms of the phase voltage you can take it, or maybe in terms of the line to line voltage. Generally, whenever we do the three-phase calculation, we all take all the parameters will be taken in consideration of per phase value. That's why it may be the V rated voltage per phase. Therefore, this is a field current. You can see that the color, this color, it is a field current which is responsible for producing the rated voltage or may be induced in case of a stator winding of an alternator. Therefore, this field current comes. This is this part. This is this part. That is, you can see this is the field current which is responsible for production of or maybe generation of or maybe the induction of inducing of rated terminal voltage across the this alternator stator winding. Then this field current, this is one more I am going to write that this is the field current. You can see that this is the field current, this field current which is responsible for circulating the rated current, rated current when we circulate the field current, it is going to produce the short circuit current, rated current in case of the alternator stator winding. Therefore, this field current divided by this field current divided by this field current will give SCR. This is the SCR. This is the meaning of the how one can determine or maybe the what's the definition of SCR, as well as how one can find out the value of the short circuit ratio for an alternator by knowing the parameters or maybe test results of OCC as well as SCC. That's why the OCC and the SCC test will become important testing methods for the alternator, the alternators. This is about the two test and determination of the SCR. Let us come on to the summary of today's class. What you learned today is the testing of the alternator to determine its the regulations, or maybe what you can call it as the parameters of the data which we require for determination of regulation of an alternator, maybe by EMF method or maybe MMF method. On the other hand, these are the parameters required, that is the parameters or maybe test results from SCC, OCC are used to determine the short circuit ratio. That is the importance of those things, are the importance of why we need to conduct the OCC as well as SCC. Now let us move on to the next thing. All the above topics what we have discussed today will come under the Bloom BLT, that Bloom taxonomy levels, that is understanding as well as remembering. For above topics or maybe any topic related to testing and commissioning of power system apparatus and its protection, you people can refer the two textbooks we can mention here. One textbook is written by S. Rao. Both the textbooks are the textbook mentioned in case of your syllabus prescribed with you. S. Rao has written the book with the title Testing and Commissioning, Operation and Maintenance of Electrical Equipment. One more textbook is available in the market written by Dr. R.L. Chakrasali with the title The Testing and the Commissioning of Electrical Equipment. The Indian standards where you can get detailed information about all the information with the specification of the synchronous machine and its testing methodology, that can be referred as such, for further the topics as such. This is about today's class. Thank you.